Hi, my name is Meshak and I'm going to be your instructor in this machine learning tutorial. In this tutorial, we're going to be building an end-to-end machine learning recommendation system. This tutorial has been splitted into 5 episodes for easy understanding. The first one, we start by building a simple machine learning model for recommendation system in a Jupyter notebook without any other thing added to it. Then in the episode 2, we're going to be introduced into DVC, data version control, and ML flow and see how they are used in machine learning operations. Then in episode 3, we're going to be training our machine learning model the standard way that helps you to understand how to set up your file and how to train machine learning model in a way that can be repeated without messing things up as one could do, especially as a beginner in machine learning. Then in episode 4, we are going to be seeing how do we build an API to use our model and to serve it into an interface. And the 5th episode, we're going to be building a ReactJS application that is going to be a movie recommendation system to consume our API, and we can see the prediction in real time. The goal of this tutorial is to help you see how end-to-end machine learning system could work, at least at the basic level, and help you to scale from there as you build your machine learning project. So this one, we start by showing you the final product that we're going to be building, which is the movie recommendation system. That is like Netflix, not necessarily Netflix, but we'll call it like Mflix. Something very simple to show you how you can take your machine learning solution from notebook and take them into usable applications. Let's go along and hope you learned something. So to start this episode, it is very important to see what does the final output of what we're going to be building, what is going to look like, the movie recommendation system. And we have this called Mflix, and Mflix is the output that we have. So I didn't just want to mention Netflix. So let's just say Mflix, something that is very minimal. Of course, Netflix is a very bigger product than something simple like this. But I believe that you're going to learn something interesting through the process of building it. So the way this works is you can put in a title. So I would say true crime, for example, and say get recommendation, and it's going to give me the top 5. And I can also say top 3, and I can get true crime. Then I can search for, let's say, Toy Story, for example, and say the top 3. So here is not showing the poster because the API where I'm fetching the picture from, these titles are not served in the database. So that is why we have no poster. But so long the picture of the movie is inside the database where I'm getting the pictures from, it will surely show. So that is exactly how it is. This is what the final product looks like. And you can take things further from here, like go do something that is bigger than this. So from here now, let's move into the coding proper. So what we're building is a movie recommendation system, and we're building it in Python. And within Python, we need to do whatever we want to do within an environment, a Python environment, depending on the Python version that we have. So in my case, I have the environment set up already, and I can activate it right now. I have the environment set up already, but I will show you how to set up the environment for yourself. So to set up the environment, you can just use conda create. So conda create, then new environment, then call the name of the environment. For me, I call it MLOps. Then Python version is 3.11, then minus y here. The reason I'm using 3.11 is because I found it to be stable in the project that I'm doing, but there are other Python versions like 3.12, 3.12, or 3.13. But I just think 3.11 works for me and works better for this project. So when you run that, you just need to activate your environment after installing that. So here I will activate this and they conda activate MLOps, and I should have the environment. Now that the environment is set, the next thing that we need to do is we need to create some folders. And to make that easy, I have created a .sh file. So in the GitHub repository of this project, where you find all the code, I've set everything up for you. So you just need to use the sh file to create your own. So I'll create a create.sh, I'll call it create.sh here, and I just have some commands that I don't want to run them one by one in the terminal. And what this is doing is just creating directory, like this directory for data, raw, the processed directory, the notebooks where we're going to be doing our experiment. Then we have the source, which is we have the source, which is going to be the data. We're going to have models, we're going to have inference, then touch create specific files. Make directory, mkdir creates the folders that we're going to be having. So to make this work, we just say sh and we run create.sh. When we do that, it's going to create all the directories and the files that we need that we're going to be using through this project. Okay, so we have the data processed. The next thing that we need to do then is we need to have the requirements, that is those files that we want to use for our project. That is the library or the packages that we want. So here I have the packages for you, and I'll just paste it here. And we're going to be using pandas, numpy, scikit-learn, fast API, which is what we're going to be using the video API, the UVCon, which helps us to serve the fast API, and then MLflow, which is going to be like our ML operation package that we're going to be using the DVC for our data version control, python.env for handling our environment file, then the request is going to be useful within the API, and job lib to be able to like package our model and make it more modular. Once you have your requirements.txt, the next thing would be to then install them. And for me, I prefer to use conda to install these files. So if you want to do it, just say conda install c conda forge, then file requirements.txt. I found this to work for me, and hopefully it works for you at the same time, but this works very well. It installs the requirements directly. I'm not installing it from scratch because I've installed it before and I don't want to have like conflicts in my installation. So if you run this, you're going to have the installation for yourself. Now that that is set, the next thing is we need to go into our data folder and say data. We go to just say cd means change directory into data. Then we go into the raw because we want to get our raw data into the folder. We say cd raw. Now that that is there, then we need to download our data. To download our data, we're going to download our data from this link. I'm going to paste it here. And also you're going to find it in the README file that is in the GitHub repository. And I'll say wget and say HTTP files. So we're getting it from group lens, is the movie lens data that we're going to be using for our project. And I'm going to run that. And that's going to download my data set for me. Now we have it saved. You can confirm. We have it in the raw, you can see. But it's a zip file. For us to use it, we need to unzip it. So to unzip it, we just say unzip. Just call it unzip, very direct. We just say unzip ml 100k .zip. Then I'll run that. And we have our data set unzipped for us to use. So that is what we have. Then I will go back into my root directory that is where my folder is stored. And I'm going to just say cd ... just to go back. And with that, we've been able to set up our environment. We've been able to create the folders that we need and some files that we need. We've been able to install the packages and we'll be able to download the data set. So the first thing in a data science project or a machine learning project is experiment before we build something that is finally standard. So and to do our experiment, you do it inside our train.iapmb, that is Python notebook. So and to do that, we are going to have our Python notebook file and you select kernel, and in the select kernel, you select the environment that you create, that has been created by you. For me, it is MLOps. Now I have that there and I'm going to create the first part. The first thing I need to do are the libraries that I need for the work I want to do. So these are the libraries that I need: the OS to handle my directories correctly, the pandas, which is the data science library that we use to process our data. Then we have the TF IDF vectorizer, which I will explain later, and the cosine similarity. So now that we have the libraries, they've been installed before, then I'll load them and then bring in my file. So my files, I have them, I call it item path, which is going to be the file I'm going to be using. So it is the u.item, which is from the raw, the ml100k, what we unzipped here. So I'm going to be using the u.item. That is what I care about for this experiment. So let me close this. Okay, that is what I care about for this experiment. And I'm going to run that. Now that I have the item path, I need to load it in form of a CSV. Then to do that, I'm going to say item and say pd.readCSV and specify the item path, and I need a separator. Okay, I need a separator and the folders that I need. So this is not what I want it to be. This is like my auto suggest, just doing what it likes. So here I'm just going to have it from the encoding to the use columns right here, and have it here and explain them as I paste the code right there. Now we have the separator. This is the header, which is the header is none. Then the encoding. Then we are selecting like there's 3 columns, which is the 0, 1, and 2, the item ID, the item title, and the release date. So we don't really need the release date in what we want to do. So I'm going to remove the release date. So we just need the item and the title, item ID and the title. That is all we care about as we load this data frame. Then we have the items. Okay, oh, sorry. Yeah, these are some of the errors. So I need to have this because I just need the 0 and 1. So let's just see what our items look like. Then I'll say items.add just to view what it looks like. So you have the item ID, you have the title. So these are the things we need for our movie recommendation. Then we have that, and we need to drop anything that we don't need. For example, missing value. So in case we have missing values in our titles, so we can easily drop the missing value by just saying drop.na, then the subset is title. So it's going to do that and drop it. So we have everything in a clean way for what we want to do. Okay, so before I move on to the model itself, there are different ways to build a recommendation system, and I'm going to be explaining them individually right here. So there are core types of movie recommendation system. Number one is content-based filtering. And what content-based filtering does is that it recommends items that are similar to those a user liked before based on the item attributes. So for example, recommending a science fiction movie to someone who liked other science fiction movie. So if I've seen a science fiction movie before, it will recommend science fiction movies to me because science fiction movies, they're similar. Or if it's a crime movie. Then for collaborative filtering is the second type. And what it does is that it leverages user behavior. So for example, if user A and user B, they like similar things, the system will recommend item user B liked to user A and the other way around. So let's say I've seen a movie titled Terminator and I'm user A, and you've also seen the movie titled Terminator, you are user B. So after seeing Terminator, let's say I also went ahead and I watched a movie like House of Cards, that is more like a political movie. The model, we recommend House of Cards to you because both of us had seen Terminator together and we both liked it. So it will assume that we have the same kind of preference for the kind of movies that we watched. So that is how collaborative filtering works. So it will also at the same time recommend any other movie that you see after Terminator to me, so that it will look as if our behavior when it comes to the kind of movie that we watch is the same. So, but this can work in two ways. So the first way is it can work user-based, which is what I've just explained. The user-based is to compare the users, compare our preferences together and recommend something that we may like to each other. Then the other one is the item-based. So the item-based is it will compare items based on user interactions. But in this tutorial, we're going to be working with content-based filtering. And content-based filtering works based on the principle of cosine similarity. And I'm going to show what that looks like. So cosine similarity is an example in form of an image that I'm going to be showing here is this. So you can see cosine similarity. So this is how it works. So you have similar vector, which cosine of the angles, they are close to 100 degrees. So you have them together, they are very close. Cosine similarity can also work from the aspect of where the cosine of the angle, they are at or near 90 degrees. So these are the orthogonal vectors. You can see how they are around the 90 degrees. Then the opposite vector, they are at or near 180 degrees. So if you look at their distance, you see that they are very far away from each other, and the similar vectors are closer. So an example that helps you to understand that better is what I'm going to be using in this image. So you can see the cosine similarity. So because this is orange and this is apple, this is an apple, this is an orange, you will see that they are closer to each other in the vector space. That is because they belong to the same kind of family, which we could call fruits. For example, they are both fruits, so there's similarity between them. So that is the way it works. So the same way is going to take the title of a movie and the title of another movie and do their cosine similarity to see how similar they are, then recommend it to us. So that is how that works. That's what we're going to be building in this project. Okay, back to this part. And the library that we're going to be using for this is the term frequency inverse document frequency, TF-IDF vectorizer. TF-IDF vectorizer that we loaded in the library above this, TF-IDF vectorizer, the term frequency inverse document frequency vectorizer, so TF-IDF. And it is a crucial tool in natural language processing that converts text documents into numerical feature vectors. Convert them into numerical feature vectors because our cosine library does not necessarily see the text. It will need to see them in numerical vectors for you to be able to compare them. So we need the TF-IDF to do that. Then the next thing we do is we then do the cosine similarity by using the cosine similarity library that we've imported. So to do that, we need to first select our mass feature, and this is our mass feature. We say mass feature is 5,000. So here we have about, let me check the shape of our movie, of our item. So I'll just say items.shape. So we have 1,682. And in each of them, you have toy, you have story, you have golden eye, you have 4, you have rooms, and each of them is a feature for the cosine similarity that we want to perform. So to make it easy, because we're not spending so much time in the modeling process here. So this is an experiment now. We're going to set the mass feature to 5,000, and we now bring in our TF-IDF vectorizer. So we add a stop word as English. We care about like the English words. Then we say the mass feature is mass feature 5,000. That is all we need for our TF-IDF vectorizer. Then after that, we then create the matrix for our cosine similarity library to use. So we just say tf-idf matrix. Here we initialize it, and here we apply it to be able to create a matrix. So we have tf-idf.fit transform, and what we are dealing with is the title. That is what we're using to check our similarity. Then we then use our cosine similarity, apply it on the tf-idf matrix to be able to see the similarity matrix. So that will create it for us. That's all that we have. Now that we have the similarity matrix, we have our items. We can then use this in building the model together in a way that we can easily apply it. So we have our cosine similarity, but we can't use it directly in this form. So I'm going to show an example of how the similarity matrix work, just for it to be clear. So I have a demonstration here. Now, it's going to have the movies set in this way. So this is Titanic, this is Titanic. So if you check the similarity score between Titanic and Titanic, it is 1.00. Titanic and Avatar, for example, is 0.85. This is just an example. Titanic and Inception is 0.10. Titanic and Interstellar is 0.20. So, and it was like that. Avatar and Interstellar, Inception and Interstellar, and like that. So that is the way it works. So if I want to check movies that are like very similar to Inception, for example, I will find here that, of course, Inception and Inception, they are very similar because they're the same thing. Then the next movie that is very close to Inception in terms of similarity is the one with 0.90, which is Inception versus Interstellar, then followed by the Avatar, then followed by Titanic. Now, that is just what is happening here. That's what we're building into our model to use. So if you type, I want similar movies to Inception, it will give you let's say the top 4 movies. It will give you in this order. You get Interstellar, you get Avatar, and you get Titanic, based on the order of the similarity matrix. So that is exactly what is happening here. Then we move into the next thing, where we're going to then be creating a class that allows us to be able to use what we've built. Now we have our items, which are the movie title, then to be able to use them to make predictions. So we have the items and the similarity matrix that will be helping us to predict or to recommend a movie that is similar to the movie that we are interested in. So to do that, we are going to be using a class. Normally, you can also use a function, just a pure function for this, but I think it is more, it's just something that is nice, or let me say best practice, to use a class for this. So we call the class movie recommender model. And within the class, we're going to create a constructor. So the constructor that we're going to be using is going to take 2 things. It's going to take the item and the similarity matrix. Now, you see, this is our constructor here. So it's going to take, we have the self, usually within our constructor, that helps us to create objects that can be used within the class in the methods that we're going to have following this constructor. So we have the items, it's going to take the items, it's going to take the similarity matrix. So for every time that we want to instantiate this class, we will need to pass in the items and the similarity matrix at every time. So we have then the items will be passed into this object that's called self.itemLookup. Then the similarity matrix is going to be passed into this object called self.similarity matrix. Now that we have that, we just need to define our predict method. So our predict method, we then take self, we pass self into it so that we can have access to those objects that we had before, and we say model input. For our model input is going to be a data frame. And why data frame? It is because sometimes you may want to check recommendation for more than one movie together. So we have it as data frame. Okay, so we have it as data frame, and the model input is a data frame. So you create the data frame that will contain the title and the top K. And the top K is simply the top number of movie that you want to check, because do I want to check the top 100 movies similar to this, top 50 movies, top 5 movies, top 6 movies? That is what you're going to have. But for this to work, we need to loop through the data frame. We need to loop through the data frame, and the way we loop through the data frame is using the iter row. That's how we loop through data frame, and I'm going to be explaining it in a way that is clear. So we have the iter row, and the iter row here is working as we say. It releases 2 values whenever you loop through a data frame using the iter row, which is the index and the row. But because we don't really need the index in this process, we just use an underscore that is just throw away the index. We care about the row. Now, the next thing is we need to then grab the query and the top K, which has the value from each row. So we have the query, which is a string value. So this is the title. I will set a default value, it is empty here. Then for top K, let's say there's no top K inserted, it will assume 5 for it whenever it wants to make any kind of prediction. So the top K is just the top number of movies that are similar to the movie that we're checking. Now the next thing will then be to do the matches. So it is very important to check this part, because if we don't check it, our model will be prone to error. Now the matches will look into the item, which is this, into this object, item lookup. So all you just want to do is this title that I want to check recommendation for, does it exist inside the item that I've received? So The item lookup is like, okay, these are all the movie titles that we have. Does this title that I built my similarity matrix on, does this title exist? That's what we are checking. So within that object, we say self.item lookup. We look at the title, that is the title that we have the title within the item lookup. Then we say, does it contain the query? That is, does it contain this title that we are passing in? So that is all this place is doing, because if it does not contain it, then we don't need to do the other process. So we just return a kind of error response that says, oh, title not available. But since we are looping through a data frame, we don't want our process to just stop. So to do that, we're going to say if length of matches, that is if the title does not exist, because match is supposed to return a list to us. So if the length of matches is equal to 0, then append an empty list. So for us to append, we need to create this result list here, an empty list called result. So we call it result. Then this result is what we take whatsoever title that we get from the recommendation process. So we have the results, then we append it. So just append something that is empty for that specific row. Then move ahead within the loop to the next row. That is, if there are any matches at all, grab the index of the match. So within the item lookup, we want to grab the index of that match. So don't mind this, the auto suggest that I have set up in my code. Then the next thing would then be, we need to check the similarity score. So based on that index, we look into the similarity matrix using that index to be able to get the similarity scores. So the similarity scores is like, get the scores of all the movies that are similar. So what we are trying to get here now is something like this. So it's going to compare them. So what we are grabbing our similarity score is those comparison of movies. So Inception versus Titanic, Inception versus Avatar, Inception versus Inception. So it's going to get those similarity scores. That's what we are getting here. So from those similarity score, that is where we are going to get those movies out. So to be able to do it easily, we will need to sort the similarity score. So this is an example here. You can see this is not sorted. So if this was sorted, we're going to have Inception versus Inception as the first one, then followed by Inception versus Interstellar, then followed by Inception versus Avatar, then followed by Titanic. So this is 0.9 or so, that is it. So that is the first thing we are doing. So we are sorting it, our similarity score. You saw the similarity score in reversing order. So we saw the similarity score in reversing order. That is, go from highest value, highest similarity to lowest similarity. Without passing the reverse equals true, it's going to be from lowest to highest. Now that we have that, we can then graph the top indices of those movies that are similar to our movies, so that we can then go into the item lookup and grab the exact title. Because remember, in our similarity score, they are simply values, they are vectors, they're just numbers. So we don't know what title they are exactly until we just grab their index and use them within the item lookup to grab the exact title of those movies that are similar. So to do that, we grab the top indices, and this is where our top K will be useful. So we have our top indices, and this is a list comprehension that goes through the similarity score, which is a list. The list comprehension goes through the similarity score. Then it will start from index number 1. Index number 1, not index 0. Normally Python will index this way. You have 0, 1, 2, and 3. 0, 1, 2, 3, 4, 5. So to do it this way. But if we check this place where I did this illustration, if we are to add an index to this, this is index 0, index 1, index 2, and index 3. You will discover that Inception versus Inception, that is the same movie, their similarity is 1.0, that will always be on the index 0 because they are very similar. But we don't want to return the same movie. So as a result, we skip it when we are grabbing our index into our top indices. So we skip 0 and we start from 1. So now that we start from 1, we start from 1 to the top K. So if the top K is 5, is the top K is 6. So let's assume the top K is 5. If we don't have this plus 1, we're going to be having just 4 outputs because now we've skipped the first one, which is 0. But by adding plus 1, then we are able to get 5 exactly. So it's going to be from 1 to 6, because in Python we always ignore the last value. So if I say index 0 to 5, I'm going to be getting 0 to 4. It doesn't take the last value. So here, so that we can get exactly 5, we say plus 1 because the 1 is going to be ignored and return the exact 5 that we want. So that is what we do with the top indices. Now that we have the top indices, our final recommendation would then be using the top indices to look into the item lookup, to check the item lookup for those titles. and we just say use that as recommend. Then we say self.item lookup dot using the iloc top indices, then the indices that relates to this title, grab the titles related to the indices and pass them into a list, because we have more than one title. We could have more than one title so long we have 5 or 4 or 6 or movies, more than one movie that is similar to the movie in question. Then finally, we append our results to the results list. So we append our results to the result list, and that is the end basically here. But our method needs to return something finally. That is this result. We need to return it at the end of everything. So we just say return result. And that is our model. It is ready right now. Then we can test the model in the new cell. So I'll just load it and say, let's test the model. So to test the model, I'll create this data frame. I'll call it input.df. And you can see the data frame contains the title, Philadelphia story, and the top K is 5. So to view it in form of a data frame, I will just input.df.add so that we can see what it looks like. And you can see title, Philadelphia story, top K 5. So it's just the same thing here. So to use it, we need to instantiate our class. Then I will just say model equals to movie recommender model. I remember it's going to get the items as part of the parameters, then the similarity matrix, because those will go into to be stored as the object that will be used by any method of the class. So we pass the similarity matrix, we pass the items. We have them here. You can see our items and we have our similarity matrix. So those are the two things we need for our model to work. Now that we have that, we just need to run prediction. So we say predictions equals, then we say model dot, we call the predict method, predict, and we say input.df. Input.df. And we can print our predictions at the end of it all and run it. So you see, we're able to get our output. So for the first movie, we have this first list. So movies that are similar to Philadelphia story, you have Philadelphia, you have Pinocchio, you have Fantasia, you have Rebecca, Toy Story, in the order of their similarity. Also, movies that are similar to Toy Story, you have the Pyromaniac's Love Story, Story of Xinghua, in 1933 Philadelphia story, and yeah, also. So this is how our experiment looks like, and that will be the end of this episode 1 of this tutorial, where we move to the episode 2. And the episode 2, we're going to be looking into like DVC data version control and be introducing you to MLflow, so that we can then begin to build out this project in a way that we can then use it for our API and serve the moderator of our API for our React application. So if you've enjoyed this, like and comment if you have questions, and I'm sure to answer them in the comment section. And at the same time, subscribe to Learn with Meshach so that you can get updates whenever new videos are being released. So watch out for the episode 2 that will be coming after this video. So you see it within this playlist as you see this video. So hope this was helpful. See you in the second episode. Thank you.